Good day everyone, my name is Herman Dorland. I'm the Managing Director of the Workshop et al., a geological consulting company in Johannesburg. Geological variables are often viewed deterministically, where a single outcome is predicted for variables from geological models. However, before a variable is measured, its predicted outcome has many possibilities described by a probability distribution. Currently, coal geology is often described in a deterministic fashion that is an oversimplification of reality. In the current deterministic description of coal geology, standard crust sizes are used during washability experiments. In southern Africa, top size for laboratory test work of -25 mm is often used, disregarding the liberation characteristics of the coal. This has led to copy-paste plant designs that may not be appropriate for deposits. The laboratory washability result is only one snapshot of the washability, disregarding what will happen if the coal was crushed to a different size. Coal core is described in a general qualitative fashion, where often the only valuable information is the measurement of the thickness of the seam and the sample positions. Geological models based on this type of data gathering are deterministic by nature, where only one possibility for mine and plant design can be modeled. Single financial models based on these geological models only evaluate one design that does not reflect the probabilistic nature of the variables on which it is based. This leads to often overlooked risks, since only the risks characterized by the data gathering and deterministic geological model can be evaluated. There are a lot of evidence that indicates that geological variables are probabilistic by nature. Many sedimentary rocks are products of turbulent flow that is not understood very well in terms of its physics. Coal in the same fashion shows high variability in product yield content at the same crust size washability. Different phases that can be distinguished based on observation have overlapping concentrations of product yield. So the phases may look different, but the same amount of product can be produced from them. Product yield is variable if washability simulation is performed several times on the same particle size distribution. Each time a sample of coal is crushed, a different washability develops. Product yield varies with crust size for the same sample, if the sample is virtually crushed several times during simulation. The value of the unknown points in the model is best guessed as a probability distribution and not a single deterministic outcome. The probability distribution for the unknown points for a large crust size forming large particles in a southern African coal are indicated. A widespread probability distribution is observed that indicates that the estimate is highly uncertain. At this particle size, a product yield of 20% is produced. When the samples are crushed to a medium particle size, a different outcome for the probability distribution of the unknown points develop. In this case, a probability distribution with a narrower spread than for the large particles develop, indicating that the outcomes are more predictable. At this crust size, a product yield of 40% is produced. If the same samples are crushed to a small size, the probability distributions of the unknown values becomes narrow and predictable. The product yield increases to 60% at this particle size distribution. This summary plot shows the probability distributions of the same unknowns when the coal is crushed to different particle size distributions. The large particles have less product yield and a wider probability distribution than the medium and small particles. Therefore, depending on crust size, different plants will lead to different economic outcomes for the same resource. These economic outcomes should be compared to select the most optimum plant design for the project. Due to the unknown value being estimated having a probability distribution, the variogram model of the unknown values consists of a whole range of possible variogram outcomes. Even if the variogram model collapses to a single variogram outcome after laboratory measurements are made, the probability spread of the range of variograms still exists in the deposit. For coal, to describe the variography therefore implies a family of variograms that changes as the particle size changes, and not just a single snapshot variogram. The large particles that have a wider probability spread reaches the sill at a much shorter distance than the medium and small particles that have narrower probability distributions and behave more predictable. The following are recommendations by the workshop et al. To describe coal for a probabilistic evaluation. Coal drill core should be logged quantitatively. Washability could be simulated for all practical particle size distributions to guide plant design. Seam height could be modeled to find its probability distribution to enhance mining equipment selection. Plant, mine and financial models should reflect the probabilistic nature of the geologic variables. Quantitative risk analysis should be performed. There should be an emphasis on discovering risk and opportunity that is not visible using deterministic methods. The three main benefits of viewing geology probabilistically are that descriptions will be closer to reality, more realistic mine, plant and financial models will result, and there will be increased understanding of risks for lenders and investors. The workshop et al. Recommends that the following could be done to implement a probabilistic view on geology. Firstly, training in university should be focused to show the probabilistic nature of geology. Industry short courses can be developed to train professionals. There will be benefit to companies since they will understand risk and opportunity better. Technology should be developed to enable probabilistic geology. Research may be performed to gain deeper understanding about the aspects of probabilistic geology. In conclusion, a probabilistic view on geology will lead to value-adding work and increased mitigation of risk, increasing confidence in mining operations. Thank you for listening.